Okay, so here we are. Go to Tools, Solid Cam, New, Milling.
Collector lives in the past of 2 days ago.
And Solid Cam will start up here. We'll choose an external part, inch over metric for this part. And so it's going to try to define, it says it's automatically defined. And if you like where the zeros are set, it's the top of the part in the center. If you like that, go with it. If you don't, I'll show you how to change it. So to change it, you go to Coordinate Manager, open it, edit it, click the edit button right there, and then you can just select a face, which will, you can see there, it's that's a good way to do things. So let's do it there. Choose that, and in this box you can choose your tool start levels. So I always set that at 2 or 1.5 just because the gantry is not real high. So you can see the part upper level is now 0, part lower is a -1/2 inch. So that looks good to me. Okay, so to start machining it, you right click operations, add a milling operation, and the first one will be a pocket. In this box you choose geometry, so we'll click this button here to select geometry, and I just select this circle here, and you can see it recognizes it as a closed loop. So that's all we need to do there. We'll select a tool. Let's use a 1/4 inch end mill. The levels, this is kind of how this program works. You click upper level button and choose the top, and you can see 0 in this box. The pocket depth, you'll click literally the pocket depth, and you see -0.2. And then we can say equal step downs, or if it's a deep pocket you can do that. This pocket will just do it with a single pass. And the technology, you can choose these different, like there's a plunging pattern, hatch goes back and forth and then finishes the walls, but I just like contour. Choose to start the inside or outside. You can climb or conventional mill. You can do these different styles of step over. But the link, this is basically how it ramps in. You can do it vertically, but if your tool's say a fly type cutter like on a wood router, then it can't cut in the center, so you can't cut vertically. So we can do a helix, and we'll set it to 10 degrees or so. It's an aggressive helix entry. And let's calculate that path and see how it looks here. You can check this box. You can see the tool path, the helix goes down, and it cuts the part. Okay, so we're happy with that one. This next one, since it's a similar procedure to cut this deeper pocket, we can just click this one, edit it, and save and copy the path, and then all you need to do is change the geometry. So we'll choose this circle here, and you'll see the tool is saved. You need to change the levels, so the upper level now will be there since it's already been cut that deep, and the pocket depth is 0.3 inches, and we'll do the equal step downs. And so you can see now it will do that deep pocket with the same helix pattern. And the last operation will be to cut the outside out, so we'll do a profile cut. Tool, We'll select the geometry, which is the outside, and need to say that it's a loop. The tool, we've already got a 1/4 inch end mill selected there. The levels, upper is 0. Profile depth is the back of the part. The technology, we're going to equal step down roughing, and we'll do 1/4 inch steps. Actually, we'll do 225, so it leaves a small pass at the end. No finish, and we'll have no wall offset, so it finishes in one go. And the link, the lead out, given we're going to cut just a profile, we don't want it to lead out or it will plunge into full depth material at the end, so we'll have no lead out. And you can lead in if you want. Let's just, I'll leave it at an arc, you can see how that looks. So we'll check the box, just look at the tool path, and you can see it leads in with an arc, but it leads out with no arc, or else it would cut deep into this. So if you're happy with how all those look, you can simulate it with a solid and watch it cut it out. Speed it up a little here. It says that will take 8 minutes and 6 seconds. It'll be a little faster than that if you want it to be, just by overriding the feed rate on the machine. And that's how you make code. I'll show you how to make the Gcode. So you'll choose the solid cam operation, Gcode Generate, and here's the code. The only part, this is a Fanuc post processor, so the only part that will not work properly is this last command right here, because it has 2 G commands in the same line. So all you need to do is delete those. Basically those say to offset the tool back to where it was at the beginning, but it's not important. So that's it.